Well, so I think this chapter has been quite long, right? For a long time, we have been studying about it. Already classes we have done. This is the seventh class, and I hope it should be finished by today. So if you see this, right, we last time studied about surface area of three-dimensional shapes and polygons. So when we studied about polygons, that was first thing, which was 2D shapes only. Then we studied about cubes and cuboids, right? And we said it
Yes,
is
sir.
2 into LB plus BH plus LH. That was the area of cuboid. And the area of cube was 6L because all the sides are equal. 6L square, right?
Yes.
All right. So now let's study about surface area of a cylinder. So tell me one thing. How do you think we can visualize a cylinder? For example, if I give you a rectangular paper, right? If I give you a rectangular paper, can you transform this into a cylinder? You think so?
Yes, sir.
How come? How can you do that?
Sir, by folding it?
Right. So if you fold it and you meet its both the ends in a curved face manner, it will become a cylinder, right? So it is, so which means it is other way around also, which means if I give you a cylinder and if I open it up, it will take form of a rectangle. Am I right?
Yes.
Right. So if I just assume that this was a cylinder, for example, and in your syllabus, we have only right angled cylinder, which means they have a 90-degree angle with the centers, right? For example, this here they are always 90 degree to this surface. Okay, it's always 90. So, which means if I just open this paper, which is kind of just assume this fact there is a paper in the cylindrical format which is covered across this particular cylinder. Right? If I open that paper, how will that open up to? So, for example, this is your R. This is your R. This is your H. This height is your H height, and this is your R height, right? Give me a second. This service. Right. Talking about the fact that if I unfold this particular paper, which is on that particular cylinder, right, it will form a rectangle. And when it forms a rectangle, what do you think? What do you think this rectangle would be? What do you think? It would be 2R. It would be, just imagine the fact, because we know the circumference of the circle is what? We know that already, right? So it is exactly the same length which is covered here, right, by this paper. So the length of this rectangle would be 2 pi r, and height will be the same, which is h. So far, so good. Any questions so far?
Yes, sir.
This is very important to understand that how can you visualize a rectangle into a cylinder as well as a cylinder into a rectangle, right? Now, apart from this part, which is rectangle, which is this paper which is covered over here, we also have these two circles here. Do we have? One is here and one is here, right? What do you think is the surface area of this circle? It will be pi r square. Similarly, the surface area of this circle would also be pi r square, because we have already assumed the fact that in the case of a right angled cylinder, these two circles are congruent. When I say they are congruent to each other, which means the radius of these circles are exactly same, the center points are exactly on the same lines. That is why if the area of this circle is pi square, then in that case, the area of this circle will also be pi r square. And we have already found out that area of this particular paper, which is curved surface, which will be transformed into rectangle, will it be equal to 2 pi r into h? Because what is the area of rectangle? Length into breadth. Length is 2 pi r and breadth is, it is 2 pi r h. So total surface area, is this clear, Vidhi? Because this has to be very clear, right? How are we calculating this? So total surface area of a cylinder is equal to pi r square plus 2 pi r h plus pi r square. This is equal to 2 pi r square plus 2 pi r h. We can take 2 pi r as common, can we? And we can write
Yes,
r
sir.
plus h. This is the formula of the surface area of a cylinder. That is it. The moment, if you remember, we talked about one concept last time, that when we talk about the volume of a, not volume, when we talk about area of three-dimensional shapes, we always talk about surface areas, because there are different types of surfaces on that particular, and there is a height also. So you, for example, in this case, you have one surface is this, second surface is just is a circle, and third surface is this entire curved surface, right? So that is why they call it surface area of a cylinder. So surface area of a cylinder, in this case, it will always be equal to this particular area plus this particular area, and then this area also. So for example, if, how do you find out that concept? If I were to paint the cylinder, then will I paint it on in that direction, that I'll paint the entire curved surface, I'll paint the top circular part, and I'll paint the bottom circular part also. Will I do that or not? Right?
Yes,
That is
sir.
why we call it as total area of a cylinder. Now, a very simple question if I ask you, right? Find the height of a cylinder. Question I am giving you right now. Height of a cylinder you have to find out, where radius is 7 centimeter and surface area, total surface area is equal to 968 centimeter square. Right? We just need to find out the height of that, for which radius is 7 centimeter and total surface area 968 centimeter square. So you need to understand that in the case of cylinder, you'll always get this as well as the height. Now we already know that the formula for total surface area is 2 pi r into 2 pi r into r plus h. This is your formula for. So this is given to us as 968 centimeters. Am I right? Now
Yes,
I
sir.
am given r, but I am not given h. This is what I have to calculate. 7 plus h is equal to 968. 14 pi into 7 plus h is equal to 968. Right? 7 4s are 18, 28, 98 pi plus 14 pi h is equal to 968. Right? Now 14 pi h, I can take pi as 22 by 7 here. Okay. So 98 into 22 by 7. This is one number. Plus 14 into 22 by 7 into h is equal to 968. So far, so good.
Yes, sir.
If I cut this, for example, 98 into 4, this 14 to the 28, 2, 14 to the 30, 308 plus 44h is equal to 968. So 44h, equations, we already know how to solve equations, right? So I'm not talking about those parts because this is something known to us. We have learned that already. It will be 0, 6, and 6, right? And h is equal to 660 upon 44, which is 460, 15 centimeter. Is it making sense to you? Right. This is the question we have to do. In a building, there are 24 cylindrical pillars. The radius of each pillar is 28 centimeter and the height is 4 meter. So just see the difference between the units. The radius is talked about in centimeters and height is talked about in meters. So we just need to ensure that we are on the same track in terms of converting the units later on, right? Find the total cost of painting the curved surface area of all pillars at the rate of rupees 8 per meter square, which means there is a building here. I would say there's a building here. In this building, there are a lot of cylindrical pillars, right? You have one, you have second, Then you have some more. So I mean, there are a lot of, I'm not going to create 28 cylinders here. Right? The idea is that there are such 28 such pillars in this building, right? And then this is like, not, yeah. So just assume this is the back side of the building. They are touching the wall. Even these are touching the wall, and this is the, what is 3D kind of shape. So the idea is that you have these 28 cylinders and you are given the radius. Radius is given as 28 centimeters. I told you because radius is given in centimeter and height is given in meters, and cost is given to us in meter square. So it is always good to convert centimeter into meter because everything else is in meter. What is 28 centimeter? It would be equal to 0.28 meters. Am I right? Is this making sense to you? Why are we doing this? Vidhi, can you hear me? Hello. Okay. So we are converting this radius from centimeter to meter because everything is in meter otherwise. So it is good to convert it into the same unit, right? Now it is asking us the cost of painting the curved surface area of all pillars at the rate of 8 rupees per meter square. These are all pillars for us. I have to find out cost, and these are all exactly similar pillars. All 24 pillars are exactly same. So if I calculate the surface area of one pillar, I will know the surface area of 24 pillars would be how much, right? Now, the interesting part here is, this was a very important part here. They're asking about curved surface area. They're not talking about total surface area. Do you understand the difference between curved and total? We talked about it. Total means curved surface area plus area of those two area of those two circular bases also. One is the top, one is on the bottom. Now in this, you just need to calculate curved surface area. Now curved surface area of a cylinder is equal to 2 pi RH. And we are told that pi can be equal to 22/7 in this case. So 2 into 22/7, R we are given 0.28 into H. This would be equal to 7.04 meters square. Because we are told that there are 24 such pillars, how much is the area of 24 pillars? 24 pillars. So this is the area only of one pillar we talked about. So 7.04 meters square. It will be equal to 168.96 meters square. This will be the area of 24 pillars. Now we are given that cost of painting 1 meter area is equal to how much? Rupees 8. So cost, that is why, since cost of painting of 1 meter square area is this, therefore cost of painting 168.96 meter square area is equal to what? 8 into 168 point. Simple unitary method. The only thing we need to consider here is, first of all, it is asking about only curved surface area. And when I talk about curved surface area, I just need to bother about this particular part, not these circles. That is why I have not used the formula of 2 pi r square plus 2 pi rh. I just use 2 pi rs. So it is very important, wherever you're given only the question of curved surface area, you should talk only about 2 pi rh. Only when you're asked about total surface area, you should be talking about 2 pi rh plus 2 pi r square, because in that case, you have to also consider those circles, right? Now, let's move to the next topic. Next topic for us is volume of 3D shapes, and it's the last topic for the chapter mensuration for the class 8, right? So I think after this topic, we will finish the chapter mensuration. Now, if you remember, we talked about some time back when we were studying area, right? In terms of area, what we do, we calculate it in terms of square units. So on that graph, we used to calculate the square units, and we said that the combination of these squares would be the area. In this case, because we are talking about 3D shapes now, we will talk volume in terms of cubical shapes. Volume in terms of a cubical shape. So which means that we are kind of calculating all the volume in cubical format, which means we are assuming that this is 1 meter, this is 1 meter, and even this is 1 meter. And if I kind of do 1 meter into 1 meter into 1 meter, it will come as 1 meter cube. Right? So it is not a square in this case because we are multiplying it by 3 times. Area, we are multiplying it 2 times. I mean length into breadth or pi r square, whatever we studied, right? In this case, it will always be in cubes. So that is why the basic unit we take in case of volume is meter cube. Okay, that is very important. Now, for example, if I say 1 meter, this is 1 meter cube, right? If I want to convert this 1 meter cube, centimeter cube, then as I said, it was 1 meter into 1 meter into 1 meter. So this 1 meter can be written as 100 centimeters, 100 centimeter into 100 centimeter into 100 centimeter. So it will be equal to 1,002, 20 from here, 20 from here, and then centimeter cube. So you can imagine the difference it brings just by adding one dimension to it. Just imagine, right? You a simple code. Will you be able to store anything there? Will I be able to hold water, any liquid there, or anything on that particular two-dimensional shape which does not have a height? Just a flat surface. Will I be able to store any liquid there? Tell me. I will not be, right? That is why three-dimensional shapes, we have the concept of volume, which means it is the amount of the item or amount of space it can occupy in that particular thing. For example, if I want to fill a cube with water or with any liquid, or even a big, for example, there is a big 3D shape and I want to fill it with cubes, right? I should be able, the entire space which I occupy, this is called as volume, and it is not different from capacity also. That is what is called as capacity. When you say capacity, it is also the volume. The only difference is in the units. In terms of volume, we talk about meter cubes or centimeter cubes. In terms of capacity, we talk about liters. I'll talk about the concept that how are volume and capacity related in terms of their units, volume and capacity. We'll talk about it in a little while. But just understand, right? So in the case of, for example, in the case of simple rectangle, we were finding out the area was this area. Am I right? In case of volume, whatever you, because it also has a height. There are 6 such surfaces in this particular case. Here it was one surface. Here you have 1, 2, 3, 4, 5, 6. And I hope you know that what is a vertex. This is called as a vertex in a cube. This is called as an edge of the cube. And this area is called as face of that cuboid. Am I right? Similar concept goes for cube also. The only difference is here you might have a cuboid. For example, if I just want to make it a cuboid, so I need to look at it a little differently. This could be like this. If I am making a cuboid, that it is not a square, it is a rectangle into 3 shape. We know the difference, right? We have studied the difference already, difference between cuboid. So you have this length is L, this would be your H, and this length would be your B. This length would be your B. So as per some analysis, what they have understood when they tried to put those cuboids in a particular go down, which is just to calculate the particular volume of the cuboid. In that case, they found out that volume of this cuboid, I mean, amount of space it can occupy is equal to L into B into H. This length into breadth into height. This is the volume of a cuboid. Okay. Now, just assume the same thing in case of a cube, because cube is a 3-dimensional extension of a square. We talked about it. All these sides are equal in the case of cube. No side is different from each other, right? Which means it is exactly symmetrical. No side is different. So just assume the case of volume equal to length into breadth into height. In case of cube, L, this is also L, even this is L, and even this is L. We know that, right? So it will be L into L, which is equal to L cube. It will be equal to L cube. Now imagine, just notice one more thing. This volume is equal to L into B into H. And we already know that the area of this rectangle is always equal to L into B. So what we are trying to do is, for example, if I talk about this particular rectangle, it is L into B. Area of this base, if I just want to transfer this concept, if I consider them together, L into B, then this L into B is actually what? Area of this base into height of this particular cube, right? I can also write it as area of base into height of cube, because sometimes the questions are like this only. I have been given area of the base and height, and then also I need to calculate the volume of cuboid. So they don't give me L and B sometimes separated out. So they can give me area of base. The same concept is here. So L square into L, which is also, that will also become L cube. Now, just imagine this thing here. If I took the same concept of cylinder here, then by observation and by experimentation, it has been found out clearly that even the volume in this case conceptually is equal to, we know this is R, radius of the circle, this is also R, and this is height, the height between two circles here, right? Now, in this case also, it will be equal to area of base into height, right? Now, what is the area of base in this case? Because base is not rectangle or a square. The base here is a circle. The area of the circle is equal to pi into r square into h. H is your height. Pi r square h. This is the volume of a cylinder. Do you have any questions in understanding how did we calculate volume of cuboid versus cube versus? That is why I just wanted to show them together so that you can do a comparison. And why there is a difference between the volume of these three-dimensional figures, and how can we correlate them together? So you can see everything is area of base into height. Now, in case of cuboid, cube area of base was L into B and L into L. In case of cylinder, the area of base is equal to pi r square. That's it. That's the only difference. So tell me if you have any questions here so far on this concept. So I am assuming no questions because there is no sound from your side, but silence I can say, right? Right. So we said that volume is the amount of space which is occupied by this entire object, right? Similarly, capacity is also the quantity that a container holds. I mean, so they are not different in terms of actual thing, but then from terminology perspective, this is the space. I mean, whatever space can hold is called as volume. And when I say capacity, which means whatever capacity, whatever quantity of that particular material it can hold is called as capacity. Now, for example, if I say a water tin holds 100 centimeter cube of water, for example, if I say that, then the capacity of that tin is the same. This is the volume and this is the capacity also. Both of them are same in terms of 100 centimeter cube. However, as I said, capacity is sometimes measured in liters also. Now, what is the relationship between meter, centimeter, centimeter cube, or liter? This is something we need to understand. This is equal, 1 meter cube is equal to 1000 liters. Just imagine this. Just know this concept. This is very important. When I say 1 meter cube is equal to 1000 liters, just imagine a cube where your length, this one, length is 1 meter, this is 1 meter, and this is 1 meter. So imagine a tank which is cubical in shape, which has the same length, same breadth, and same height of 1 meter each. Then the amount of water it can contain is 1000 liters. Just imagine this fact, right? So the tank, water tank on the terrace of your flat, just go tomorrow and see what is the measurement of those length, breadth, and height. Once you do that, just multiply them together, because if you multiply them, you'll get the volume, and you will immediately know that this is the volume of this tank. I mean, it may be, for example, your length is, for example, 10, your breadth is 20, and the height of this tank is again 5, for example, right? Then tell me the volume or the capacity in this case. So volume or capacity, both of them would be equal to 10 into 20 into 5. Right? So it will be equal to 1000. In this case, also 1000. So even your dimensions are different, but as I told you earlier, if your length, breadth, and height we know about it, then we can always calculate length into breadth into height, and that will give you the volume of the thing. We just need to understand the relationship between meter cube and liter. This is the relationship. Because your 1 milliliter is equal to 1 centimeter cube. For example, if I have a very small shape of cube, which is 1 centimeter length, 1 centimeter breadth, 1 centimeter height, it can only consume 1 milliliters of that particular liquid. Right? And that is why 1 liter is equal to 1000 centimeter cube. Because 1 liter equal to 1000 milliliters, right? So which means 1 liter equal to 1000 millimeter cube, which is what we have said here also. And that is why we are saying 1 meter cube is 1000 liters. So 1 meter cube is a bigger number again. Because it is meter, 1 meter into 1 meter into 1 meter, which means if I say 1 meter cube, which will be equal to, just imagine this, right? 100 centimeter into 100 centimeter into 100 centimeter. So how many hundreds are there? Zeros are there? 1, 2, 3, 4, 5, 6 centimeter cube. This, what happens? Something went wrong. Give me a second. Already understood the concepts in the previous slide, previous board, that what is the volume of a cylinder, what is the volume of a cuboid, what is the volume of a cube. So now we'll talk about some questions here. We also understood the relationship between capacity and volume, that 1 meter cube is equal to 1000 of liters. 1 liter is equal to 1000 centimeter cube. Now the question is that we have to find out height of a cuboid. You have to find out h of a cuboid. Volume is given to you as 275 centimeter cube, and base area is given to you as 25 meter square. Now, if you remember, this is where I was telling you that formula of volume of cube or volume of 3D shape. In this case, it is volume of cuboid. If you remember, we talked about it is area of base into height. We also read this formula apart from the formula of L into B into H. In this case, because they have already given us because they have already given us area of base, that is why we are not bothered about length into breadth. Okay, area of base is, now volume is given to you as 275, and it should be in cube. It is not square, because volume is always in cube, because there are 3 dimensions to it, right? So you always have to multiply it by 3 times. Area is 25 and height is something you do not know. Now, if I solve this equation very simply, it will be h equal to 275 upon 25, and it is equal to 11 centimeters, right? Very simple question, but this is where the formula of volume in terms of area of base into height matters. Just imagine the fact, if you were only aware of the formula of L into B into H, you could not have been able to solve this question, because you're not given L and B together, right? So this is where it becomes important. Now,
Okay, sir.
any question here? So this is why this formula is important here, right? So if no questions, then we will move to the next one right now. The next question for us is, a go down is in the form of a cuboid of measures 60 meters into 40 meters into 30 meters. So imagine this is a very big go down. 60 meter, do you understand the length of 60 meter? It is very big, right? When you run for a 100-meter race, you can imagine this much amount you have to run. Just some part of it, 60% part of that, that is the length of that go down. 40 meters is the breadth of the go down, and 30 meters height. So 30 meter height is actually very high, very, very high, right? Because if you see the height, or in our room, general room, it is around 10 to 12 feet. So when I say 12 feet, then also it is around 4 meters. So 30 meter height is like too much. Okay. The question is, how many cuboidal boxes can be stored in it? The volume of one box is 0.8 meter cube. Now, if you remember, we talked about this case just now, that in case of three-dimensional shapes, either we talk about surface area or we talk about volume. In this case, because it is talking about the capacity, it is asking you how many boxes can you store. If volume of one box is this much, then you will always find out you will not talk about surface area. This is because surface area is only for the surfaces. Now here we're talking about filling the entire godown with these kind of boxes. So there is a big godown. For example, there is this big godown, and in this big godown, you need to, and it is like three-dimensional shape. So you can just draw that here. It is cuboidal, like cuboidal godown. Right? This is the godown. Now here they start putting those cubes. I mean these boxes, cuboidal boxes, and these are also cube, right? So this is how they have to put so many boxes here in the entire godown, and they can fill it up to the height. So what we need to find out here is the volume of this. Sorry, we need to find out how many cuboidal boxes can be stored. So if you remember when we talked about the area in two-dimensional shape, and we said that okay, if I have to tile this particular floor and the entire area of this particular base is this much and the area of this tile is this much, then we used to divide that number, right? The entire area is this much, and your one area of one tile is this much, then we'll find out the number of tiles if we divide the number, because we understood that this, it will come here, it will come here, it will come here, it will come here. So it will be a very simple mathematical equation that I know area of one tile and I know the area entire base, so I just need to divide the number. Similarly, you have to do it here. You have to find out number of boxes in this case will be equal to the volume of entire godown, which is the bigger godown, divided by volume of one box. That is it. The same concept which we applied for tiles, the same concept we have to apply here also for volume. Because the logic is same. We have to fill the entire room with those boxes. So if we know the volume of the entire room and I we one box, we can easily find out how many number of boxes can be put in there. Does that make sense? Right. So if you see this 60 into this, the volume, what is the volume of entire godown? 60 into 40 into 30. And what is the volume of this one? 0.8 meter. This is also meter cube, so no worries, they can be cut together. Tuck, tuck, tuck. Use the CB this here. 8 5s are 40, 6 5 30, 3 9 90,000 boxes. So see this. If one box is only having a volume of 0.8 meter cube, then you can actually put 90,000 such boxes in that godown. Any question? Right?
No, sir.
Okay. So we'll just do, so we have done a question. We'll just do one more question for cylinder and then we are good. This particular thing. Yeah. So I'm just, let me write in the question, let me clear the canvas. So the last question of this series is, and it is going to be easy one because in the case of cylinder, generally they don't go so much difficult. A rectangular paper of width 14 centimeter is rolled along its width and a cylinder of radius 20 centimeter is formed. Find the volume of the cylinder. Find the volume of the cylinder. So what should we do here? For example, see, we just learned in just few minutes back, if I roll a rectangular paper from its width or from its length also, what does it turn into? It turns into a cylinder. We just learned it, right? When we are studying the volume and surface area of the cylinder.
Cylinder, yes, sir.
In this case, for example, this is a rectangular paper where the width was 14 centimeters. The width was, this is width, right? 14 centimeters.
14 cent.
We are rolling this particular along the width, which means we are rolling it this way. Which means this area, this line will become 2 pi r. Last time we just talked about it?
Yes, sir.
Right. This whole length will become 2 pi r, and we are also aware of the fact that it makes into a cylinder, and cylinder is like this. So tell me one thing, this height is equal to 14 centimeter. Can we say that?
Yes,
And
sir.
we know this radius is 20 centimeters. This radius is 20 centimeters. Because it is told to us, a cylinder of radius 20 centimeters, and this height is 14 centimeters. We have seen that because this height is this width, right? Because we are actually folding the paper as per this width. Now, we know height of cylinder is equal to 14 centimeters. We know radius is equal to 20 centimeters. What is the volume of a cylinder? What is volume? Just learn the formula. Pi r square h.
Yes.
Right. So pi is 22 by 7 in this case. What is r? 20 into 20 into h, which is 14. I cut this 7 to the 14. 200 into 800, 22 into 8, 17600 centimeter cube. Because everything we have to multiply. See, r square, centimeter square, h is centimeter, centimeter square into centimeter equal to centimeter cube. And we can always verify that volume should always be in centimeter. So this is very important to understand. See, in this volume, all you had to do was actually to find out the height here, right? Because radius was already given to you. And how did you find out? You found out the height by knowing the fact that this rectangle is rolled along its width. That is why this width becomes its height. So if you want, we can just talk about one more question, such question, and we can then it would be more clear. Is it clear at least for this one? Why this height is 14 centimeters of the cylinder, right? Okay, so let's do one more question, the final question. Right. So the next question, the final question of the day, for this chapter is this question: a rectangular piece of paper, a rectangular piece of paper, 11 centimeter into 4 centimeter is folded without overlapping, which means actually it is creating a cylinder only, right? If you're folding it, it will create what? Cylinder, and no overlap is there to make a, which means we are making both the corners or both the edges meet together to form a complete. I mean, you can ignore this word, it is just to confuse you, otherwise it has nothing to do with overlapping to make a cylinder of height 4 centimeters. Find the volume of the cylinder. Now tell me in this case. See, first of all, we should always understand the question in terms of what is given to us, this is given to us, and this is to find out. We are given rectangle, length and breadth, and we are given cylinder's height. Right? Three things we are given. We are given this, we are given this. We need to find out volume of cylinder. Now, what is volume? It is pi r square h. So all we have to do is to find out h of the cylinder and r of the cylinder. This is only we have to find out. Am I right? So h of the
Yes,
cylinder is
sir.
given to us already. This is a cylinder. We already know this. So this question is completely up to what is the r of this particular cylinder, right? We do not know the r, but we know one thing, that if this is rectangle, we have already learned it some time back. If this is height, this is 2 pi r, right? And this is your cylinder. That is why it is always important to understand the concept, because only formulas will not help you. Even to use formulas, you need to understand how and where can I fit things, right? This is r. So which means what? If we know that this particular height is 11, we know that because we know height is 4 centimeter, right? Which means we were given the fact that your rectangle was 11 into 4. We were told this is 11 into 4. Now it is telling you also that to make a cylinder of height 4 centimeter, which means they have rolled this paper like this, so that height remains 4 centimeter. So this height is actually 4 centimeter to you. This is 4 centimeter. And 2 pi r, so 2 pi r is what? 11. 2 pi r is equal to what? 11. So your r will be equal to 11 2 pi, which is 22 upon 7. 2 7 by 4 centimeter is your radius. Volume we already know, it is pi r. It is pi r square into h. So pi is 22 by 7. What is r? We just calculated r, right? 7 by 4. And it is square. So 7 by 4 into h is 4. We are already given h here, 4. So that is why it is always important to visualize shape, visualize a question in terms of geometrical figures. Because it will always help you to understand, okay, what is it that I've been given? What is it that I have to calculate? This will make things for you, right? So that is why I'm saying so. So it is 38.5 centimeter square. In this case, we were not even told that rectangle has been rolled along its width. We were just told the dimensions of rectangle 11 into 4, and it created a cylinder of height 4, which means it clearly told us the height of the cylinder is 4, which means this width is 4 and length is 11. And when you say length is 11, you know the length is 2 pi r. That is why this was the most important thing in this question. This was the most important thing. Why did we do this? We are clear on the question. Okay. So for me, this marks the end of the chapter mensuration. This is the 7th class. I think it was the longest chapter we've ever had, 7 chapters, because we also combined the concepts of class 6, 7th, and 8th, because we studied it right from the basics, right? Just right from the basic perimeters, area, and everything, 2D, 3D shape. So I think we've covered quite a lot. And this is what is there in till 8th class. After that, if we want to go, we will begin about it later. If you have any questions, just ping me. We'll study it. So now I'm just stopping this recording.